All right, so let's look at some general motion graphs. So in your constant acceleration activity, when you graphed position versus time, position on the vertical axis, time on the horizontal axis, meters, position is in meters, time is in seconds. You got a increasing position over time, like this. So we can translate that into a generic velocity time graph to show that that object was speeding up. It was speeding up, but it was also moving in the positive direction. At positive velocity, it was moving to the right, moving in the positive direction. So the position time graph shows me it's speeding up. The slope of the tangent line is positive all the time, and it's increasing. And my velocity time graph shows me the same thing. All of those velocity values are positive. The slope is the acceleration. And the slope of this line would be positive because it's a up and to the right positive slope, just like from math class. And all those would be positive velocities on the vertical axis. So that means if our velocity is positive, and I'm going to show that with a positive arrow. Remember, velocity is technically a vector, which means that it has magnitude and direction. And if the acceleration is also positive, that acceleration is causing that velocity to increase because you're adding that acceleration vector to the right, to the right, to the right. So we get speeding up. So a position time graph and a velocity time graph that match each other, that both show me they're speeding up, look like these two graphs. Now there's a second version here. I have a position time graph where the object's moving to the right, but as it moves to the right, it's slowing down. So think about an example of this motion. It's moving, but slowing down. So maybe that's an object that's, the brakes are being applied. Maybe it's an object that's rolling uphill. So this shows me it's slowing down because the slope of the position time graph goes from being very steep initially to being very flat later. But it's still moving in the positive direction. So you can move to the right and slow down at the same time. So that means our velocities are positive, but the velocity goes from being very positive. So there's my little dashed tangent line there. It's a very positive number and a very positive velocity on our graph of velocity time, to pretty much zero slope there. So at a later time, our velocity is 0. Mark that on your velocity graph. Then we're going to connect those two dots. So velocity is initially very positive and very large. Later, it is much smaller, nearly 0 from my graph. Probably stops. The slope of a velocity time graph is the acceleration, and the sign for the slope of this graph would be negative. So this is a negative acceleration. It's moving in the positive direction. So if I draw some arrows to represent the motion, the velocity is positive because the object's moving to the right. It's going from 0 to some positive position. But my acceleration is negative. So it's not pointing to the right. Instead, it's pointing to the left. So that means for every moment of time, the velocity is decreasing. So we call that slowing down. So these two graphs match each other. The velocity time and the position time for slowing down and moving to the right. All right, we can make another. There are 4 total. So this will be our third one. Now, we've gone to the right twice. Gone to the right, speeding up and slowing down, and that's it. So now we're going to move to the left. Left would have a negative position. Right's positive, left is negative. And if we start at t equals 0, and let's have this object speed up as it is moving to the left. So it's covering more distance. Remember, distance is just how far. Position or displacement is the vector. It has the direction. So initially, our velocity, the slope of the line, is about 0. But later, our velocity is negative. It has a very negative slope there. And remember, you can't go slower than stopped. So a negative velocity simply means direction. So this is speeding up, but moving to the right. Left, moving to the left, speeding up, moving to the left. And on our velocity time graph, I'm going to draw this velocity time and times in seconds. The initial velocity is nearly 0, so we can mark that on our velocity time graph. We have positive velocities above the time axis, negative velocities below the time axis. And much later, the velocity is very negative. So let's mark at a later time a negative velocity. Connect those 2 points. And now remember, the slope of a velocity time graph is acceleration. The position time graph shows me it's speeding up. And in the negative direction. This velocity graph shows me that the acceleration, or the slope, is negative. So now let's draw arrows. So if I use a negative or left pointing arrow to represent the velocity and a negative or left pointing arrow to represent the negative acceleration, notice those 2 arrows are in the same direction. So we're actually making the vector bigger by adding a negative to that negative. So we'll get that the object is speeding up, it's just speeding up to the left. Remember, you can't go slower than stopped. So a negative velocity simply means that it's moving in the negative direction. Alright, so we should have a third one here. So we're going to move to the left again. Position is on the vertical axis, time is on the horizontal axis. Meters and seconds are our units. And then this one needs to slow down. So we start out initially with a very negative velocity and it goes to 0. So we've got a negative velocity to begin with. And it goes to 0. Then we can make so this shows me that it's slowing down. The slope goes from being very negative to being 0. And remember, a negative velocity just means it's moving in the opposite direction. So it's slowing down, moving in the negative direction. Let's draw the velocity time graph here. So we've got a velocity on the vertical axis, and we have time on the horizontal axis. Velocity is in meters per second, and time is in seconds. Initially, our velocity is very negative, so we'll mark that on our velocity graph. At t equals 0, v is very negative. And then at t is something bigger, our velocity is almost 0. Connect those two dots. Now I've got the slope here is up and to the right. From math class, I remember that that is a positive slope, so that means the slope of that velocity time graph is a positive acceleration. Then we can draw the arrows to represent the motion. So your velocity vector would be to the left because it's negative. From the position time graph, I know it's moving to the left because it goes from 0 to a negative position. But the velocity time graph shows me the acceleration is positive. So those two vectors are opposite of each other. And so the positive acceleration is actually causing the negative velocity to decrease, so it's slowing down.